Read the black thing. Just read the black thing.
This isn't the exemplar exam.
No, I have it in my mobile.
Okay.
When you were finding the omega, which T did you use?
This is a question we did in semester 1. In fact, it almost looks like the same as the question in the worksheet. Question number 3 or 4 possibly, on the lesson sequence and series practical problems.
But we have like two information. Like we have like sum of it or something, we need to make the formula. But if they give you only one thing.
The second, fifth and 11th terms of an arithmetic are consecutive terms of geometric, and the 7th term is 4. Find the first term. No, that's enough information. Is this the paper from, or this is just a physics
No,
paper?
that's the paper for me. He gave me the question first. He's like, okay, you want to solve something? Solve it.
Have you got the paper?
Yeah. Yeah, just go on the left.
You have a question on the last paper.
This is Jo's paper. She can't type. She made up these questions.
If the front page was example or something like this.
The other time she typed it up, but I can tell that it's hers because if you look at the footer, it's a footer from a Word document, whereas the footer from the NCK documents are like this. There's no border on them. So she typed this up in Word.
She's messing with it.
She typed this up in Word. She might have copied some of the questions from exemplars. Yeah. Don't worry, Fahad, I'm not holding out on you. You have the most recent paper, which we'll do this week. And if you want, if there's time, I can even look at that impossible one.
No, I solved it in the end, but it took me time.
Okay, congratulations. So, what was your question to begin with?
Like, I just want to confirm that we have a say, like the...
Yes, Fahad, I haven't lost my mind. When I said I'll give you an exemplar paper, I really meant it, and the one I gave you on Friday really was an exemplar paper. Thank you for being concerned about my sanity.
It's not, I just want, because I saw it says part 2, and on the semester 2 it says part 2.
All is okay now,
Yes.
alright?
Which T did you use for the last one, for the omega?
I didn't use it. For the last part, you don't need a T. You just need A equals omega squared x.
No, not for the last part, for the part before that.
0.066
Even 0.
for small t.
Yes.
Yeah?
You can't use that T.
Why not? I got the right answer.
No, that's for the small T. I'm talking about for the...
Oh, the big T? Oh, I don't know. I just typed it in directly. You still feel like it's 90 seconds
No.
to swing up and down. Yeah.
There's no method there. I calculated it, I got 12.
Great.
That was for the omega. The time is 0.52 seconds.
Hang on. What's the formula? 2 pi root m over k, is it? Root m over k?
Mm-hmm.
Are you sure?
Yeah.
Yeah.
0.52.
Mm-hmm.
Yeah, so?
Then
Yeah.
you said you use 0.06.
For the small t. This is the periodic big T. Okay, I'm continuing now because I'm tired. Right. Okay, this first one is standard enough. We've seen as a section A question before. He's recycling a little bit here. You have your E, and you have your internal resistance or, and you have your external resistor or, and when the, and of course you have a voltmeter as well here. No, is it a volt? No, not a voltmeter. You have an ammeter. So when the or is 6, the I is 0.39, and when the OR is 4, the I, oh no, sorry, when the OR is something else, it'll be 0.24. Now, the reason I said something else is that what they said happened in the question was that you connected it together with a 4. So when they're in series, how does the resistance combine? It just adds directly together. So in fact it's a 10 here. So this is what you have at the beginning, and then later you have this. So if you use Kirchhoff, E minus I, looks so messy. E minus I or minus 6I equals 0, and then here E minus I or minus 10, 0.24 equals 0. So you can write this as E plus, you can write this as E minus 0.39 or equals 6 times 0.34, and E, minus 0.24 or, yes?
You're going to which way?
What? What do you ask me?
Why is smaller?
Why is what smaller? Why is what smaller?
The small r.
Internal resistance.
But where is the 4?
Where? Here?
The 4 resistance.
Yeah, they're put together to make a 10.
But you wrote 6.
Yeah, because at the beginning it was 6.
Yeah.
Wakey. Wake up. Let's go. Right. 1 minus 0.39. 6 times 0.34. So E is 2.976 volts and or is 2.4 ohms, which, let us check if that is correct. No, it is. I actually accidentally did a part way later. This is actually part 3 and part 4. I skipped part 1 and 2. Right, so that is correct, by the way, for... No, it's not. No. Or 0.4, and I got 2.4. Way off. Maybe I misread and I'm going too fast. E internal cross 6, 0.39 volts. When a 4 is connected in series with the 6, it falls to 0.24. So E minus I or 6. I mistyped. My handwriting is bad. This isn't 0.34. This is 0.39. This is what went wrong. So, retyping. Much better. E equals 2.496 volts, and then I, wow, that made a big difference. Now the I is correct, 0.4 amps. So, yeah, I know. You wouldn't think it, would you? Sorry, or. Right, so now actually on to part 1 and 2, which I skipped over. Part 1 is what is the power? So when they're connected together. So what's the formula for power? Yeah, there's a couple. There's IV and there's also I squared or, isn't there? Yeah. I'll use this one. So I got 0.576 watts, which is correct, and then the next part is what is the current at over 5 seconds? Yeah, well, Q equals IT. Wait, really? Yeah, okay. So 0.24 times 5 is 1.2 coulombs. Right, so that's part A done. Now on to part B. B part 1. What is Kirchhoff's first law? So that's the junction law. Kirchhoff's first law says that if you sum up the current at a junction, the total should be 0. And what's the second law? That the voltage around a loop in a closed circuit will total 0 as well. And then C is nice. I like these ones. Yeah, oh sorry, it's gone, Jeff is messed up.
Kirchhoff.
Our buddy Kirchhoff. Do you like Kirchhoff now? Good. Yeah.
It's good math.
Good. Right, C part now. So, well, routine. You have a circuit you want to solve, yeah? So we'll just make the equations. That's good. Yeah, so let's start with 10, okay? So we have 10. Now I'm going to the left. So 10 minus 5 times 3, and I'll go up the top, minus 6 times I1 equals 0. Now I'll go from the E to the left. Or I could also go from the 10 but then go around the bottom.
You can make the upper one.
I just made the upper one. Maybe I should make the lower one. I'll make the lower one. E minus 5 times 3 minus 8I2 equals 0. And then junction rule says that I1 plus I2 minus 3 equals 0. Oh my goodness, it couldn't be that easy. Because what does this one give me? And once I have I1 I have, and once I have I2 I have E. Right, so what is I1? So I1, 10 minus 15 divided by 6, so I get minus 0.833 amps. And then I2 would be 3 minus I1. So then I2 I got is 3.833 amps. And so then E will be 15 plus 8I2. So I got E. Now, these numbers look a bit too big. They make me worried. But I am correct. Wow, that was super quick for 8 marks.
Good. Not even a minute.
I don't even think it was 60 seconds, was it? For 8 marks. You see, so I like the electricity question. It's a great question. I mean, pretty straightforward. Okay.